Okay, welcome to Kramer's Victims Unite. Now this is our third installment in Chapter 6, and it is the general probability rules. I'm Peter, and this is...
I'm Matthew.
Now, I'm going to start us off with a definition of union, because we'll be using that a lot throughout our presentation. Now, the union of a group of events is the event in which at least one of the groups occurs. Okay? So the addition rule for disjoint events, which is probability of one or more of A, B, and C, is equal to the probability of A plus the probability of B plus the probability of C. Now this rule can be applied to any number of disjoint events. So say you had 5, you could also use this rule. Let's take a look at a diagram. This is a Venn diagram of 3 disjoint events. You can tell that these events are disjoint because they are not overlapping, and thusly they will not occur simultaneously. Okay, now if 2 events are not disjoint, they can occur at the same time. Now the probability of their union is less than the total sum of both their probabilities. The general addition rule for unions of 2 events is for any 2 events, A and B, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now when 2 events occur at the same time, they are joint events. Use a chart like this to find the joint probability of these events. So here we're given a chart. Now in a real life question, you won't be given all of these numbers, but you can find them out really easily. Let's take a look at this over here. The total and Joe winning the game. Now we might not be given the probability of Joe losing the game, but we can find that out extremely easily by subtracting the probability of Joe winning the game from the probability of the total. Another important thing to remember about these charts is that whether you add the horizontal probabilities together or the vertical probabilities together, they will always be equal to 1. Now, Matthew will talk about conditional probability.
So conditional probability is to find the probability of one event under the condition that we know another event. So for this probability, we could write as P, probability of event A given by event B, where event B is a given condition. So for example, what is the probability that a person has a bachelor's degree given that they're over 25? It is given in a question that the number of people receiving a bachelor's degree would be 15,000, and that would be event B, while the number of people over 25 would be 9,400, which is event A. So to calculate the probability, we'll just divide 9,400 by 15,000, and it will equal to 0.627. And for the general multiplication rule for any 2 events, it would be equal. So it would be P of probability of A and B, that would equal to probability of A times probability of B given by A. And the probability of B given event A would equal to probability of A and B divided by probability of A. And here from now on, Rambor will take over for the lecture.
Welcome, Rambor!
Okay, thank you, Matthew. Good job. Okay, so now we move on to the to another rule in our probability. So if A and B are any events whose probabilities are 0 or 1, then the probability of A given B will equal this. This is called Bayes' rule. And when 2 events A and B are positive and are independent, then the probability of B given A will equal probability of B. Okay, Peter.
Rambor, I was wondering a little question here. Okay, now how many, what's the percentage of college heavyweights that make it into the professional game?
Alright, so heavyweight boxers, alright. So that question here can be explained very clearly in the tree diagram. Alright. over here in section A of the tree diagram shows the percentage of people in college who are heavyweight boxers, which is 15%. 85%, A complement, or a complement of A, are the percentage of college students who are not heavyweight boxers. Then going on to B, 17% of the 15% of college students who are boxers went professional, while 83% of them didn't, therefore complement C. And looking down here, 11% of the 85% of people who went to college and weren't heavyweight boxers did go professional, okay, while 89% didn't. Now keep in mind that we may have these probabilities, but we just want to explain this important concept in this chapter, the tree diagram. Okay, that will conclude our presentations for chapter 6. Thank you for watching.
We hope to bring you more videos in the future, if not by us, but by other students. You can get the account username and the password to this account from Mr. Kramer. And if you'd like, please add some more videos to help our fellow students.
Okay, and thank you goes out to Kevin for filming this section of
Kevin
the video.
Zeng.
Okay, and so thank you for watching. Goodbye.
Matthew says bye too, so.
Goodbye.